my suggestion is that you work the problem, then watch the video to see what I get for an answer. For number 1, so again, I'll give a pause to allow you to stop the video, but I'm going to continue on. Determine if the following is a probability distribution. There are 2 things you need to ask yourself in terms of this type of a question. 1, the probabilities each have to be between 0 and 1. And that is the case for these, right? The first one, the second one, the third one, and the fourth one. The total probability, when you add these up, has to add up to 1. If you add 5 to 35, you get 40. 40 and 40 is 80. 80 and 20 is 100%. So yes, that is a probability distribution. For the second one, when I look at each individual probability, it's between 0 and 1. When I add them up, 5 and 36 is 41. 41 and 40 is 81. 81 and 20 is 101. So that's 101%, which is over 1. So this one cannot be a probability distribution. Notice I don't care about the outcomes. The outcomes are not my concern. Outcomes are just what they are, whatever they are. Moving on, I am going to skip number 2. I'll get back to this one later, but essentially I'm not going to really go through number 2 because it's really just too lengthy to explain in a video. I have it worked out on the answer sheet for you, so I suggest looking at that. I'm going to move on to number 3. I want you to read the problem. Notice you're not going to be given any of this on the test. This was for practice. It was telling you what to do. But this is a binomial distribution problem. Why? There are 2 things that can happen. I am picking students. I'm picking 20 students, so I'm doing something over and over again. I'm finding out if they graduated or did not graduate. So that is a binomial distribution problem. The first problem is asking what's the probability that I get 2 students that drop out. Well, when I have an equal sign, I have to use the formula. And that formula is C of, how many do I get to pick from? 20. How many am I selecting? 2. Then I multiply that by the probability of what I am counting or what I am selecting. I am counting the number that dropped out. The probability of dropping out is 10%. So 0.1. How many? 2, so I'll raise it to the second exponent. Multiply that by the probability that you're the opposite, you're not dropping out, which is 0.9. These 2 probabilities have to add up to 1. How many are not dropping out? Well, if there are 20 students and 2 are dropping out, that means 18 are not. Now you clean this up by doing the calculations. C of 20 pick 2 is a combination pick 2, meaning no order, correct? So 20 times 19 divided by 2 times 1. I'll use the fancy calculator. Then I'm multiplying that by 0.01. Just doing the math here. And then 0.9 raised to the power of 18. Yeah, to the exponent of 18. 0. That's a 0.1501, round into 4 places. If you do your math here, you're going to get your final answer, which is approximately 0.28518. Moving on, this one is asking for the probability that 1 graduates. In other words, this is the probability. Now, X is representing the number that graduate here, okay? So X is 1. Well, again, I'm calculating the probability of a binomial equaling a number. So my first thing to do is I need to calculate the combination of 20 pick 1. What's the probability of what I'm counting? I'm counting those that are graduating now. The probability of graduating is 0.9. How many? 1. Next, the multiplied to the probability of what I am not counting, those dropping out, 0.1. How many of them? 19, because again, if I have 20 in total and one of them's graduating, it must mean 19 are not. Now we look at the combination formula. 20 pick 1 is just 20 over 1. 0.9 to the first power is 0.9. If you enter 0.1 to the 19th in your calculator and you round it to 4 places, but really, even if you round it further than that, it's essentially 0. So there's essentially no chance at all of this happening, that only 1 out of the 20 students actually graduate, okay? Because if you think about it, on average, if 90% of them are graduating, that means on average 18 are graduating, and you're saying only 1 is. So the answer to that one is 0. The previous one is 0.28518. Notice again, if you look at the formula, this probability here is the probability of what you're counting, dropping out. This probability here is what I am counting, those graduating. The exponent is how many. And then the probability next to it, the probability next to it is the opposite. So you know these two probabilities add up to 1, and you know the exponents add up to the number you're picking. But the important thing is identifying the problem, that this was a binomial problem. For C, again, you should stop the video. I'm going to work it out. For C, I am looking for the probability that at least 3 drop out. That is, x is greater than or equal to 3. Now, x is counting those who dropped out. This is a binomial inequality. As I told you, you need to convert this to the normal approximation by either adding or subtracting 1/2. So the first thing I am going to do is I'm going to write this as the probability that x, sorry, I got to erase that now, that 3 is less than or equal to x. Well, again, if you draw a line, here's 3. I'm going off in this direction because I'm above 3. I want to include 3, so if I'm including 3, I'm going to have to start off at 2.5. So this is the same thing as the probability of x being greater than or equal to 2.5. Now I want to get to the normal approximation. In order to get to the normal approximation, I need to know the mean. For a binomial, the mean is n times p. In this problem here, I am counting dropouts. So n is equal to 20. The probability of dropping out is 0.1, and that is equal to 2. Sigma is the square root of npq. Well, I'm going to let you do that part. That's just plugging in the numbers. N is 20, P is 0.1, Q is 0.9. Multiply, take the square root, and you're going to get 1.3416. Now that I have the mean and the standard deviation, I get to the table, how? By subtracting the mean and dividing by the standard deviation, correct? And now I'm working with a standard normal random variable. This is equal to the probability. When you do the math here, you're going to get 0.37. Now this is opposite of what the table gives me. Remember, the table tells me everything below a number. So I'm asking for what's above this number. So whatever the table tells me, I'm going to be subtracting this from 1. And if you look this number up in the table, you're going to find, if you look up this number in the table, you're going to find it is 0.6443, the associated probability, which then is equal to 0.36. So there's your answer. Why not add a little color to this, huh? There's my answer for that one. There's my answer for that one. Well, if you want to go a little purple here, well, purple and yellow, I guess, gives you a little red, huh? Whatever. So we'll erase that, huh? Oh, and then we erased our answer, right? We'll put our answer back. Just having fun here. All right, moving on. Looking at number 4. I'll pause, give you time to stop the video. Okay. I am working with a standard normal distribution. Why? Because I am working with z. So this problem is asking for the probability that z is between 0 and 1.2. Since I'm between two numbers, this is going to be the probability associated with the larger number, 1.2. And if you look this up in the table, you're going to find out that that is equal to, looking it up in the table, 0.8849. That's when you look up this one, right? Then you look up this number in the table, and that is 0.5. You subtract the the smaller percentage from the larger percentage. When you do that, you're going to get the answer, and that is 0.385. Moving on, I want the probability associated with being to the right of this number z, meaning larger. In other words, this is asking for the probability that z, I'm looking to the right of z, right? So z is larger than 0.29, okay? Because that's to the right of 0.29. Well, again, this is the opposite of what the table tells me. So I have to subtract from 1 whatever I find in the table. I'll look up 0.29 in the table. That's your job. I'm not going to show the table here. I'm assuming everybody has working with the table down. 0.6141. When you subtract this from 1, you get 0.3859. So that's the answer for this part. Moving on, I want the probability associated to the left of z, meaning the probability that z is less than 2.01. To the left, right? So I'm to the left of the number. So the probability of being below the number. Well, this is the way the table works. So I'll look this number up in the table. If you look it up in the table, that's the answer. 0.9778. So there's that one, and this one. One more. The probability of being to the right of negative 1.39. So if I'm to the right of this number, I'm asking the probability of being larger than this number, correct? Well, that is, again, opposite of what the table tells me. So I'm going to be subtracting from 1. I'll look up minus 1.39 in the table, and I find it is 0.0823, and I do my math, and I get 9177. Now we get to the interesting problems, right? Number 5. Read the problem, so I'm going to pause here, assume that you read the problem, then try it, and then play the video. All right. If you look at this problem here, I'm looking for key pieces of information, all right? If you look at the question, find the probability that A, randomly selected monthly payment is more than $1,000. So I am looking at a single outcome or member of the population that happens to be normally distributed. So I am working with a normally distributed random variable. So the probability that X is more than 1,000, which is really the same thing as the probability that 1,000 is less than X, I need to get to the table. I get to the table by finding the mean, which is given in the problem, the standard deviation, which is given in the problem. I subtract the mean. And divide by the standard deviation. I'm now working with a standard normal problem. If I do the math, this comes out to be 0.1. Now I can go to the table. This is the scenario that I'm opposite to table. So whatever the table gives me, I'm going to be subtracting from 1. I'll look up 0.1 in the table and I get 0.5398. When you do your math, that is equal to 0.4602. For B, same problem, the probability that X is less than 1475. Again, the important thing to note is I'm working with a member of the population that is normally distributed. I need to work with the mean and the standard deviation to get me to the table, correct? So this is 1475 minus the mean divided by the standard deviation. When I do my math, this is Z is less than 2.74. This is the way the table works. I'll look up 274 in the table and I find the number 9969. So the probability that the monthly payment is below 1475 is close to 100%. Moving on. Well, I'm going to actually stop the video right now because I don't like making videos too long because they crash on you. So I'm going to stop this video and then I'm going to start another video. In the meantime, what you're going to be doing is working more problems, right? All right, so let me stop the video.